Hello everyone, good afternoon. How the day? What did happen? Okay, today we are going to look at absolute value graphs involving exponential and hyperbolic functions. Previously, we dealt with absolute value graphs involving linear and parabolic functions. Here we use a slightly different approach. The sketching of graph is still sketching of graph. We just have to look at the conditions, the critical conditions, and the restrictions placed on this and know how to maneuver around them. So remember, for any absolute value graph, f of x, what we actually look out for is that the expression of the value in the absolute value must return a positive or a negative. So in a nutshell, 2x minus 1 should return a positive value, or 2 exponent x minus 1 must return a negative value. So first of all, let's see a different approach to this. First of all, we sketch the graph of the positive. See, what do we need? We need the asymptotes. For an exponential graph, we need the horizontal asymptote. In this case, it is -1. We also check if we can have x-intercept, y-intercept. So for y-intercept, we make x 0. -1 or -1 is 0. So we have 0 and 0. In order to get the proper steep for the graph, we get one more point. So I can take when x is equals to 3, for instance, if x equals to 3, we have 2 to the power of 3. Or let's take 2, not to stretch it. If x is equals to 2, we have 2 to the power of 2 minus 1, that's power minus 1, which is 3. So we have 2 and 3 as a coordinates. Let's sketch this graph. Use the proper scale, 2, 4, and 6. Remember, your grid line will guide you on choosing the proper scale. Now, the first thing we always represent on a hyperbolic or an exponential graph, please always represent the asymptote first. The asymptote here is at -1, so we have -1. So after that is y equals to -1, that is our asymptote. After that, let's place our points. We have 0 and 0, which is at the origin. And then we have 2 and 3 to guide us for our steepness. So this, I want to do something else because of absolute value, so that we understand the process involved. I also want to choose another point. Let's choose -1. If x is equals to -1, on my graph, I will have 2 to the power of -1, which is a half, -1. Half minus 1 is also -half. So we have these coordinates, -1 and -half. So we have -1 and -half. So this guides us. I will explain the concept or the reason behind this extra point. We can sketch our graph to have the graph of f. But because it is an absolute value graph, we need to represent not just that graph, but the positive and the negative version of it, because absolute values must return positive and negative values. How do we represent the negative part? We don't need to sketch a new graph. It is still the same graph, but they say that this is negative. So if this is negative, we go to the section where we have the negative part of the graph and also our asymptotes, and then we reflect everything. So in reflecting this, our asymptote, which is at y equals to -1, will now become y equals to +1. Remember, reflect your asymptotes and the negative part of your graph in the y-axis. Reflecting them in the y-axis means for every coordinate, the sign for y, the sign for y changes, reflection in the x-axis. So for this, we don't need this. This is on the positive. On the negative, we still have negative 1 for x, but the sign for y changes. We have a half. So we reflected two things. The asymptote reflects back to positive, and also the points of the negative reflects back to positive. So we are going to have this negative 1 and positive half now. Also, every other point here reflects, so this becomes the new part of the graph. Then wipe out the original part. So this is the graph of the exponential function. Now let's look at the hyperbolic function. For the hyperbolic function, it is still the same approach. It is still the same approach, but for the hyperbolic function, like we know, we need the horizontal and the vertical asymptotes. In this case, our vertical asymptote here is equals to 1, and our horizontal asymptote, nothing is given for our q. So our horizontal asymptote is 0. So let's represent those two. Let's represent those two. Our horizontal asymptote is at 0. So we have x equals, y equals to 0. And then our vertical asymptote is at 1. So we have x equals to 1. Now let's sketch our graphs. We need 2 points on that side and 2 points on this side. For the positive part, I'll have x equals to 2. When x is equals to 2 here, I'll have y equals to 2 over 2 minus 1. 2 over 1 is 2. So the first coordinate is 2 and 2. If I take x equals to 3, I'll have y equals to 2 over 3 minus 1, 2 over 2. So I have 1. So I have 3 and 1 as my coordinate. Let me sketch those coordinates. 2 and 2 is this point. 3 and 1. 3 and 1. 3 and 1. So I have, remember the green line represents my asymptote here. I have this part and on this. Now on this other side, let's check if we have any, because the horizontal asymptote is 0, we cannot have any x-intercept. But we can have y-intercept. Let's check. For y-intercept, remember, make x 0. So we can have our y-intercept, it's very important. So this y-intercept will be 0 and negative 2. All we need is one more point on the negative to complete our sketch. Remember, I'm choosing all these points. I can easily draw a curve, but I'm choosing all these points because I want to get the exact steepness that represents this hyperbolic function. So, what do? Let's take any point. If I take x equals to negative 1, I'll have y equals to 2 over negative 1. Negative 1 is negative 2. 2 over negative 2 is negative 1. So I have another coordinates, negative 1 and negative 1. So let's plot those two. I have negative 2 and 0. I have negative 1 and negative 1. So this will give me the graph. Remember, no graph must bump into the asymptote. This is our f, this is a reflected f. This is our g, and this is our g. But because this g falls inside an absolute bar graph, it is an absolute bar value graph. So because of that, we also reflect, we've sketched the positive. This is the positive hyperbolic graph. So what we do, we also reflect the negative part so that we can also represent the negative part of the absolute bar. So we reflect the negative part also. What do we reflect? We reflect two things. We reflect our vertical asymptote. Our horizontal asymptote. We reflect our horizontal asymptote, which is 0, so it stays the same. And we also reflect everything on the negative to the positive. So let's look at the values we use for the negative. We used 0 and negative 2. Reflected in the x-axis, we have 0 and 2. If this is reflected in the x-axis, we will have -1 and 1. So these will form our new points for the reflected version of the graph. So let's check this. 0 and -2, this comes over here. And then we have also -1 and 1. That becomes our new point. So if we join this, we will see this is our asymptote as x equals to 1. We will see that we will now have a new graph on this. So instead of having this and this, the negative part will be reflected in the x-axis, and then we need to take out this part. So our graph will now be this, and this represents the complete absolute value graph for this hyperbolic function. Remember the process. Sketch the normal positive graph, reflect the negative part of the graph, including the horizontal asymptotes. Reflect all of them in the x-axis, and you will get your absolute value graph for all exponential and hyperbolic function graphs. Thank you. Continue to study. If you need more clarity, please do not stop. Ask questions, and I will give you more clarity. Continue to share my video. Continue to encourage your friends to subscribe and follow my pages. I'm always here to help. Enjoy the rest of your day. I'll see you next time.